Dear class, today I will continue with from the previous session, programming of 8085. Microprocessor. I'd like to use the sign using memory interfacing. Okay, why memory interfacing is useful? Because just like in the previous section of previous videos, I told you that when we add two numbers, the result is automatically being stored in the accumulator. Actually, the whole block diagram of a microprocessor, it's actually a black box. I will not be able to access any of the, it's not like I can go to an accumulator and see what is there in accumulator. For the fact that I cannot actually see any content of the registers, which I mentioned to you in the previous video, in a microprocessor. I'll not be able to see any of them. So it's actually the block diagram of a microprocessor is actually like a black box. The only way you can manipulate your programs or your results or your inputs or your outputs is by interfacing a microprocessor with the memory. And you should remember one thing also, that a microprocessor does not have a memory. You should always interface a memory to your microprocessor. Just like when you see in your computer you have a motherboard, your motherboard does not have a memory. You have to interface it, your hard disk outside of it. Okay, your processor means only your processor with only your motherboard. Okay, similarly, even 8085 microprocessor also, whatever block diagram you have noticed, that is only the processing unit. Okay, the memory you still have to interface separately. So if you wanted to use any if you want to take data in and out of the processor, you can access it using a memory, and you can see only the memory part of the microprocessor. So what happens is, a microprocessor in 8085, the address bit of your microprocessor is 16-bit. Okay, 16-bit means these memory locations, your memory looks something like this. I'll just write more lines. There is a dot because 16 bits means a lot of memory location. Okay, I'll just dot it. So 16-bit addressing means the address to these memory location are represented in 16-bit. So this will be 001H that way. Dot, I'll go this as the topmost is FFFF because it's 16-bit, maximum is FFFF. H means hexadecimal. H. Similarly, it goes this FFFD. Okay, so 16 bit addressing. Okay, now what happens is that's what. So I cannot see my accumulator content or any of the registers. So what I'll do is I'll take another program just to show you as an example. I'll call it P3 in continuation to the previous session. I'll do the same thing to add two 8-bit numbers. Okay, using in memory interfacing. So what I'll do is randomly I'll just take I'll just dot this one to show that it's some memory location. Okay, means of some memory location is there in between. I'll just take randomly some memory location in between. You can take any memory location, no restriction. This is just because I wanted to do this. I want to take these three memory location. One is to store my first number. I'll just take the previous example itself. To make my calculation easier, you can take any number. Don't hesitate to try that. So my first number is 55, my second number is also 55, and the result I'll store it in F052. Okay, since I cannot write data directly into the processor also. Okay, so I'll store these first two numbers in my memory location, then I'll try to take this data into the processor, and then I'll do some operation there, and whatever result is there, I'll write it back into my F052. That way I'll be able to see what's going on in my processor. Okay, so how do I get this data from the memory into the processor? So I'll do this instruction LXIH F050. Okay, what this does was, whenever there's an X in an instruction, it always points to an HL pair. Means to a pair of register, any register, HL pair. pair register. Suppose if I write here D, it means DE. If I write here B, it means BC. So whenever there's an X, it points to an HL pair. And L means load, I means immediate data. Immediate data means this number is being loaded into this HL pair. Okay, so at the end of this line, my HL pair is a 16-bit register because it's in a pair. So my H value will become F0, my L value becomes 50. Okay, this is how I point to the first memory location. Next is I'll try to move whatever content of this memory location to accumulator, because by default when I do add, my first data has to be an accumulator. So I have to put my first data in accumulator because of the instruction, because of the predefined instruction add. So whatever is there in memory location, I'm moving it to accumulator. Okay, the question is which memory location? Move A comma M means whatever is there M should be moved to A, into accumulator. M means memory location. There are so many memory locations. The question is which memory location? But the memory location which I have previously referred to means F050. So whatever content, remember it's a content, the content of F050 will be moved to A. That's what it means. The content of F050 memory location will be moved to A. So at the end of this line, accumulator will have 55H. Next, I already got my first data in accumulator. Now I'll try to pick up my second data. My second data is, I'll just increment it since they are from one memory location to the other. That's sequential, like one after the other. I'll just increment H. In INX H, as I told you previously, whenever X is there, we mean HL pair. INX means increment HL pair. That's what it means. So H is already, it means like this. HL means HL. So this is F0. HL is already in this program, the last updated value of HL is F050. So it gives F050 plus 1 and result is stored in HL. So this will become F051. Okay, so my HL pair after this line will become F051. Okay, so I'll add, because there's an instruction that can add directly. I'll just do ADDM. Okay, similarly here also, what it means, this one is A, first data by default is an accumulator, plus whatever you've written here. So this is M, result is stored in accumulator. Okay, so again question is which M means memory location. Which memory location? The memory location previously referred to. Okay, the previously referred to is F051. So what is the content of that F051? It's 55. Okay, so it goes, content of F051 is 55 plus accumulator content, which is again 55H, and the result is, from previous example I got it at AAH. So the result is AAH. This result is already there in accumulator after writing this line itself. Okay, now how do I get this result into the memory location? Okay, so what I'll do, since they are sequentially arranged, I'll just write increment H. Okay, increment H means again I'll increment my H. So the last updated value of H is, sorry, there should be a space. The last incremented value of H, updated value of HL pair is F051. So which means F051 increment plus 1. It becomes F052. So this will be there in your HL pair now. F052. Okay. So my pointer will point to F052 now. Once it points there, because my result is there in accumulator, okay, whatever is there in accumulator, I'm moving it to M. Whatever is there in accumulator, I'm moving it to M. M means memory location. Which memory location? The memory, I'm moving it to M. Which memory location? Memory location previously referred to, that is F052. So which means after this line, my F052 memory location will have AAH, will have my accumulator content result. Okay, so what happened is, these values you can access, you'll be able to see all these values. Okay, that's why I told you it's a black box. So you take your input into the microprocessor, do some manipulation, bring back your results and see if it's doing a task or not. Okay, so after this EAH. Okay, so now I'm done. I already added 2 numbers and that's it, I'm done. So I'll hold now. So for now I'll stop here with this one. Please go through this video and till I upload for the next one. Thank you very much.